Ever wondered how your computer understands patterns in text? The secret lies in the magic of regular expressions. In the realm of the theory of automata, regular expressions are a compact and powerful notation that describes regular languages. They're composed of characters and special symbols that represent operations on strings, forming a sort of language within a language. Regular expressions are used to define patterns that match strings in a given language. They're the unsung heroes behind many of the tasks we take for granted, from searching a document for a specific word to validating the format of an email address. In programming languages, text processing tools, and formal language specifications, regular expressions are the go-to tool for pattern matching, searching, and lexical analysis. They provide a concise and flexible way to describe complex patterns in strings. With regular expressions, we can define patterns that match strings in a given language. Dive into the world of regular expressions and discover the power of pattern matching. Symbols are the basic building blocks of regular expressions. Let's take a moment to dive into the world of symbols. In the context of regular expressions, symbols are the most basic units. They represent individual characters from an alphabet. This alphabet could be the English alphabet, with letters ranging from A to Z, or it could be the binary alphabet with only 2 characters. 0 and 1. In essence, symbols are the simplest form of regular expressions. They don't denote any operations or complex patterns. Instead, they stand for specific characters that we want to identify or manipulate within a string. It's like playing a game of hide and seek, where the symbols are the ones hiding, and the regular expression is the seeker, finding these symbols in the vast playground of strings. Imagine a string as a necklace and each symbol as a unique bead on this necklace. Just as each bead contributes to the overall pattern of the necklace, each symbol contributes to the pattern that a regular expression seeks to define or match. But symbols don't always stand alone. Often they come together to form more complex patterns. In these cases, they're strung together much like beads on a necklace to represent a sequence of characters. This sequence could represent words, numbers, or any other pattern of interest. And just as a necklace can be adorned with different types of beads, a regular expression can include different types of symbols. Some symbols might represent letters, others might represent numbers, and some might even represent special characters. The diversity and flexibility of symbols make regular expressions an incredibly powerful tool for pattern matching. So whether you're searching for a specific word in a document, validating user input, or parsing complex text files, remember that symbols are your basic building blocks. They are the simplest, yet one of the most crucial components of regular expressions, serving as the foundation upon which more complex patterns are built. Symbols are the simplest form of regular expressions. Regular expressions use specific operations to define complex patterns. This allows us to construct intricate search patterns from simple, manageable components. Let's delve into these operations. First off, we have concatenation. This is the simplest operation, represented by simply placing symbols or expressions next to each other. If A and B are regular expressions, then AB represents the concatenation of patterns, A followed by B. This operation allows us to build longer patterns from shorter ones, like building sentences from words. Next, we have the union operation, also known as alternation. This is represented by the pipe symbol. It denotes a choice between patterns. If A and B are regular expressions, then AB represents the pattern that matches either A or B. This operation gives us the flexibility to define multiple acceptable patterns. It's like saying either this or that. Then we have the clean star or closure operation. This is denoted by represents 0 or more occurrences of pattern A. This is an incredibly powerful operation, allowing us to define patterns of arbitrary length. Moreover, we have grouping parentheses. Parentheses, and, are used for grouping sub-expressions within a larger expression. They help specify the order of operations and define the scope of operations. This is particularly useful when combining multiple operations. Parentheses allow us to control the precedence of operations, much like in arithmetic. Next are character classes. Character classes allow specifying a set of characters that can match at a particular position in the string. For example, represents any digit from 0 to 9. This operation gives us the ability to define a range of acceptable characters rather than specifying each one individually. Lastly, we have escape characters. Some characters have special meanings in regular expressions. To match these characters literally, they need to be escaped using a backslash. For example, to match the asterisk character. This allows us to include special characters in our patterns without invoking their special meaning. Together, these operations provide the building blocks to create regular expressions. They allow us to define complex patterns that can match a wide variety of strings. From searching for a specific word in a text, to validating the format of an email address, regular expressions provide a powerful and flexible tool for pattern matching. These operations allow us to construct complex patterns from simple ones. They are the core of what makes regular expressions such a powerful tool in the theory of automata and formal languages. Regular expressions also have some special features that make them even more powerful. Let's dive into some of these. Grouping parentheses are one such feature. They're used to group sub-expressions within a larger expression, kind of like brackets in mathematical equations. They help us define the order of operations and the scope of these operations. For instance, in the regular expression ABC, without parentheses, the union operation could be applied to either A or B, and then C would be concatenated. But if we put parentheses around BC, like ABC, it's clear that the union operation is between A and the concatenation of BC. Next up, we have character classes. These allow us to specify a set of characters that can match at a particular position in the string. They're denoted by square brackets. For example, represents any lowercase letter from A to Z, and represents any digit from 0 to 9. We could also mix it up and say to represent any lowercase letter or digit. So, if we're looking for a pattern that includes any letter or number, character classes can make that super simple. Finally, we have escape characters. In regular expressions, some characters have special meanings. For example, the asterisk represents the clean star operation, and the pipe symbol represents union. But what if we want to search for these characters literally in a string? That's where escape characters come in. By using a backslash before these special characters, we can match them literally. For instance, if we want to search for an asterisk in a string, we would use the regular expression asterisk. These features add flexibility and precision to regular expressions. They allow us to define complex patterns in a concise and powerful way, making regular expressions a vital tool in the theory of automata and formal languages. We've covered a lot of ground today, so let's recap what we learned. We delved into the world of regular expressions, a fascinating tool used to describe regular languages in the theory of automata. We discovered that these expressions are made up of symbols and special symbols that represent operations on strings. We learned about the key components of regular expressions, symbols, which are the basic units representing individual characters from an alphabet. Then, we also understood the concept of concatenation, an operation that combines symbols or expressions to form patterns. We saw how union or alternation gives us a choice between patterns. It's represented by the pipe symbol and allows us to match either one pattern or another. We also dove into the clean star, or closure, a special operation that represents 0 or more occurrences of the preceding pattern. We observed how this operation can be used to match repeating patterns in strings. We also explored how parentheses are used for grouping sub-expressions within a larger expression. These parentheses are critical in defining the order of operations and the scope of operations. We further discussed character classes, which allow us to specify a set of characters that can match at a particular position in the string. And lastly, we talked about escape characters. These are the characters that have special meanings in regular expressions and need to be escaped using a backslash to match them literally. We also noted that regular expressions are used extensively in programming languages, text processing tools, and formal language specifications for tasks such as pattern matching, searching, and lexical analysis. To sum up, regular expressions are a concise and flexible way to describe complex patterns in strings. They are indeed an essential tool in the theory of automata and formal languages. Understanding regular expressions is key to mastering the theory of automata and many aspects of computer science. Thank you for joining us today. Stay curious and keep learning.